So we just did one. The second one is the second one is the bar graph. The bar graph, there we are given data. So I'll just put the table of that data. So the tables, the frequency table was 4.0 to 5.9, 6.0 to 7.9, 8.0 to 9.9, 10.0 to 11.9, 12.0 to 13.9, 14.0, 15.9, 16.0, 17.9. Then now I'm leaving out the tally. I'll just get the frequency. The frequency is 1, first part, 3, 7, 9, 9, 12, 8. So you can form a table which is called the bar graph. Here we have the XY plane. This time around, we are using frequency. You can choose. So now we'll put frequency this side and the intervals the other side, starting from 4.0. 4.0 to 4.0, 6.0, just getting the first numbers on the left, 8.0, you can also choose to take care of the numbers that are not represented on the graph. That is 0, then 2.0, then 4.0, then 6.0, 8.0.
With the previous page, sorry, I forgot to screenshot.
The previous page is the previous session. You can only come as a collector. And then 12.0, 14.0, and 16.0. So we know that then the frequency, I'll put it in 2, 4, 6, 8, 10, 12, 14. If you're forming a bar graph, from 0 to 2, there's nothing. From 2 to 4, there's nothing. But from 4 to 5.9, we have a frequency, and the frequency is 1. So we'll put up this thing here, it's 1. And then from 6 to 7.9, the boundary is 8. We have 3. So once it, we have 3. Then from 8, we have 7. So here we have 7. And then 10 to 12, we have 9. So 10 to 12, We have 9. So here we have 9. And then from 12 to 14, we also have 9. Then from 14 to 16, we have 12. We have 12, 15, 16. And then from 16 to 18, so we needed 18 here. 17.9, we have 8. So we'll come back to 8. A bit louder, 8. So this structure here is called the bar graph. So you can represent the intervals data in that form. Now the bar graph is different from the histogram, but they look almost the same from the histogram, which is similar to this, but have different features. Do we have any questions? Any questions, please?
For me, it is clear, sir.
Yes, it's clear.
To represent everyone else. Then we also have what we call so we only have 2 data sets. So when you're making it's not the x-axis actually, since there's no x here. So you can form a structure that looks like the x or y plane, when in fact don't have the xy. There's some structure to resembles. Okay. Then we also have what we call the scatter diagram. Or the scatter graph, where you have data.
Sir, I'm kindly asking for the previous slide. My network was tripping. I didn't know what you were doing on the graph. Yes, I don't know how you came about this.
So what we are doing is on the x-axis, we're getting this interval, and then that was the base. So we're forming the base using this interval. So we have from 4 to 6, which was representing 5.9. And then how far does it go up? It was using the frequency to go up. If it's 1, it will go up to 1. It ends there. Then you get another base from 6 to 8. From 6 to 8. How far does it go? It has 3 as the frequency, so it would go as far as 3. Then it comes down. Another base, the base of same size, that is now 8 to 10. How far does it go? 7 up. So it would go. That's how we constructed that structure there. And then next thing, on top of the scatter, so it says sketch the scatter graph for the following data. The scatter graph, you could choose to use in the scatter graph, you don't, if you group the data, it will be a bit tricky to form the scatter graph. So scatter graph, you want the data to be discrete. Discrete, you're able to count it. I have 4, I have 5, I have 6, and then you put my dots around your data. For example, in our example 1, we had now I don't have those figures, so I'll just put something similar. So 1, 1, 2, 3, 4, 1, 4, 4, 5, 7, 10, 11, 13, something like this. And then if I put maybe I don't have a wrong thing. Let me put data like 1, 1, 2, 1, 3, 3, 5, 4, 4, 5, 2, 3, 5, 5. Okay. Then so now we're saying for 1, what's the frequency for 1? You can count how many ones we have. We have 1, 2, 3. We have 3 ones. So I'm having the numbers here, and then the frequency. How often each number appears. So 1, 1, 1. So we have 3. And then the number 2 appears how many times? Twice. The number 3 appears how many times? 1, 2, 3. The number 4 appears twice. The number 5 appears 1, 2, 3. 1, 2, 3, 4. 4 times. And then to form the scatter diagram, so I will have I'll have some frequency and also some numbers. So I can choose to put the numbers this side: 1, 2, 3, 4, 5. And then for the frequency, 1, 2, 3, 4, 5. So how is data spread? So 1 appears 3 times, so I'll put the dot here. 2 appears twice, so I'll put the dot here. 3 appears 3 times. 4 appears twice. 5 appears 4 times. So just put dots around the frequency against the entries, and you call it the scatter diagram. So nothing connecting them. So this must be the easiest. And this other ones.
So you just leave them like that, you don't connect them?
If you connect them, then you're forming a frequency polygon. Just on the same data, if we say sketch the frequency polygon, of the data in 3. Then you come and connect. You connect the data. So this is called the frequency polygon. Then,
Sir,
yes.
I went away. Like you said, there is no connecting, and then I just found you. You connected the my thingy there. So I'm like, I'm a bit lost.
So for us to connect, we have to add another question.
Okay.
Yes, so you don't just connect, you can't connect if they haven't asked you to find the frequency polygon. If they ask for a frequency polygon, then you connect the points. The connecting of the points is adding to the scatter diagram. You find the frequency polygon. Now the frequency polygon can even be there on the bar graph. You'd go to the middle interval of each class, and draw a line connecting them. Draw a line like that. This is the frequency polygon. It just targets the frequency of each. Now for intervals, it gets the middle. That middle class value is the one that you're getting against the frequency. Because you know each height is in relation with the frequency. So if I go inside and connect, then I'm forming the frequency polygon of that structure which I have. Then on the same data, this data here, we can as well choose to find what we call the pie chart of the data given above, of the data in 3. To find the pie chart, you add the frequency first. Get the sum of the frequency. So we have 3 plus 2 plus 3 plus 2 plus 4. We get 14. So the sum of the frequency is 14. Then now you want to get the percentage of each frequency for the whole data. So the number 1 appears 3 times. So you'd say 3 over 14 and then multiply by 100. Because the pie chart only composes of the percentages out of 100. So you have 300 divided by 14, giving us 21.4. 21.4. 2 contributes 2 out of 14. The frequency, that is 200 divided by 14. We get 14.3. And then 3 over 14 by 100, we already calculated this one, 21.4. And then 4, 2 over 14 by 100. That's 14.3. Then 5, 4 over 14 by 100. That's 400 divided by 14. That's 28.6. And then you now form the pie chart of this thing. So I'll form it on the other side. So the pie chart. This circle here, you're partitioning it according to the percentages. So if you add these percentages, they are giving us 100. Okay. So we have 5 of them. 2 are equal, 21.4, 21.4. So then put some center. Then I do this. This is space 21.4. Another space assumed to be equal to this one, 21.4. And then 28.6. And then, in fact, there's 14.3, 14.3. So a bit smaller. Another one equal, 14.3, 14.3. Then we'll assume that, well, it looks like it's 50, but it's not 50. Okay, let's just try to stretch a bit. This one and this one. We'll have this space. And this space, so it can be beyond 50. Can be beyond 50. So I'm trying to restrict the 50 there. And then we'll come and put the 14.3. 14.3. Then 28.6. And then remember that this is for, since these are just numbers, we don't have any information about where these numbers are coming from. So say for 1 and 3, so this is for 1, this is for 3, and then for 2 and 4, and then for 2 and 4, and then for 5. So in most cases, you find that the pie chart is shaded. You can find there's some colors. This is blue, green, reddy. It's just trying to differentiate. So I formed the pie chart, the scatter diagram, the polygon using the same data. That shouldn't be a big deal on your side. And in most cases, that thing that you're seeing here as a polygon thing, that's a thing that is used on those cards. When you go home, you check your cards when you are babies. The percentage, that's like very calculated percentages when you are getting your results. If I mark you out of 60, I give you 12. And then you find on the percentage I put 2%. You guys come back and say, no, sir, this is not 2%. And calculate. How do you calculate? You say 12 over 60 multiplied by 100. So you divide 12 divided by 60 multiplied by 100. Say, no, it's not 2%, but 20%. That's how you get the percentages. So just the total 14 becomes the total. And now you start doing 3 out of 14 by 100, 2 out of 14 by 100, 3 out of 14 by 100. And then you notice that when calculating When you do 3, the next one don't even need to calculate, you just write the percentage. When you do 2, you don't write the percentage. Because even you, if you are sure your friend has done the right calculation and they have 12, then they get 20%. You don't even need to know how the conversion was. It's like, but that one has 12 and it's 20%. How come mine is not 20%? So it negotiates that they should be equal. That's how you get that information there. Okay, then the next, you can also arrange your data in what we call the stem and leaf plots. So it's just another way of arranging your data for easy calculations. So all we're doing here is just trying to put your data together, because if I've got so many numbers, so I've got so many numbers, 1, 1, 2, 1, 3, 3, what? These numbers are too many. I can put them in order, as you can see here. Where I say 1, how many ones? Instead of me going there to count 1, 2, 3, if somebody arranged for me, I will know, oh, 1 appears 3 times, or 5 appears 4 times. It becomes easy for me to interpret the data. Find the mean, I'll just get the mean because I already have. Instead of me adding 1, 2, I just multiplying for the mean. I just say 1 times 3 plus 2 times 2, 3 times 3, 4 times 2, 5 times 5 times 4. Unfortunately, time is running so fast. But nevertheless, we'll do the remaining minutes. We'll do a small example. So, draw the stem and leaf plot for the following data. The data 0, 1, 10, 9, 11, 17, 23, 29, 30, 37, 43, 46, 52, 78, 72, 81, 87, 93, 99, 98. Now to come up with a stem and the stem and leaf, you can decide to break it in any way. Okay, so in this case we have numbers from 0 up to 100 in that category, from 0 up to 99, closer to 100. So you can break it in tens. So we'll draw the stem and then attach to the leaf. And then you just demarcate by a line. So where the numbers that are single digits, I'll say that their stem is 0. Instead of me saying 0, 1, 0, 2, 0, 3, I just put the 0 on the left, and then on the right, I put what they are. So I have 0, we have 1, any other that is a single digit number, we only have 2. I mean, there's also 9. So just list them like that. If you want, you can come up with an ordered stem where you pick the numbers in ascending order, so it can be easy for you to come up, to get the mean, the mode if you're asked to do so. So the next is 10 to 20, 10 to 19. All the numbers starting with 1, 10, 11, 17, you are saying that their stem is 1. Then their leaf, 0 for 10, 1 for 11, 7 for 17. 21, 22, 23, the stem is 2. Their leaf, 23, 29. Then for 30s, the stem is 3, the leaf 0 for that's 30, 7, that's 37. Then 40, that's the stem, the leaf 43, 46. And then 5 as the stem, 52, that's one number there. Then 6 as the stem. There's no number there, so don't write anything. 7, we have 2, 72. We have 8, 78. And then 80, we have 81, 87. And then 90, we have 93, 98, 99. So it becomes easy for us to know how many numbers we have using the stem. We just come and count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 numbers altogether. So it's easy to count the numbers using the stem and leaf. And when it's ordered, you can easily get your median. You can get your mode. It's easy. Any questions?
Now, sir, from the same point you've said, how can we get using?
Sir, my network is busy cutting. I didn't understand what was happening here. I was trying to go through.
So we're saying that what we call the stem on the numbers, this thing, stem and leaf, is saying that numbers are in bundles. We have numbers from 0 to 9, we have numbers from 10 to 20, numbers from 30 to 40, from 20 to 30, from 40 to 50. Instead of you repeating, you're writing numbers 10, 11, 12, 13, 14, 15, 16, 19. The stem and leaf will just ask you to write 1 once, and then you block. 10, you just write 0. 11, you just write 1. 12, you just write 2, 3, 4, 5, 6, 9. Then when I come, I look at it. If you tell me this is the stem and this is the leaf, then I'll know that you have 10, you have 11. So I'll be getting 1 from here before I get the second one. So that's how you form this stem. So where you see 2 and then there's 3 and 9, you know you're seeing 23, 29. You see 4, there's 3 and 6, then you're seeing 43, 46. You see 9, there's 3, 8, 9, you're seeing 93, 98, 99. Now there's something that comes closer to this stem and leaf, which is the box plot. The box and the whisker plots, they are close to this. You first form the stem and leaf for easy collection of data, and then infuse in the box and the whisker. It also has got nice properties around it. That's why now we explain about the mean of this stem and leaf thing here. How do you appreciate the stem and leaf? It will give you an easy mean. Then that mean will help you interpret the box and whisker plots, which gives us so much information about the quartiles, the weight of the interquartile range, and all that. So they were able to get even the outliers, some that we call outliers. So except that time is just moving too fast. The guys were in and they are also waiting. So I just don't know if you guys do revise every after class. So my advice from today is that whatever we do before the next class, please find time, go through, because we are doing a build up. Tomorrow we also have a class. Tomorrow I will use the timetable for the next week, starting tomorrow. I'm sure we'll have class from tomorrow up to Friday, so that we can finish probability and statistics. Statistics will finish this week, then probability next week. Then we'll start doing the revisions. But for you to appreciate, after class, revise. After class, revise. After class, revise. So the day we'll say we're now doing over revisions, it will make sense to you. If you don't revise, when you do over revisions, that's when you'll be starting. So end here.
So there is a video, a recorded video I saw on the videos you upload on YouTube. Now I was confused whether the density probability we learned them or maybe it's not for us.
That's for second year.
Oh, okay.
Sir,
Yes.
I'm currently asking, did you record the previous class?
Yes, I'll be sending some.
Okay, thank you.
Okay.